Dear students, here we will continue with the mathematical tools of quantum mechanics. And today in this video, we are going to discuss projection operator. What is projection operator? So here, which one is projection operator and what is projection operator? So an operator like a projection operator be represented by the P, and operator P is said to be the projection operator or projecting operator if it is Hermitian and is equals to its own square. That is, operator should be Hermitian if P transpose is equals to P. So any operator, first condition for projection is that it should be Hermitian, that is P transpose is equals to P. And second condition for it should fulfill is that P square is equals to P. So these are the two necessary conditions for an operator to be the projection operator. Its transpose should be equals to that operator, that it should be the Hermitian. Secondly, square of the operator should be equals to the operator. Now we will discuss the properties of projection operator. That first are the properties of projection operator. So the projection operator, that is the product of two commuting operator. Let we have the two operator P1 and P2. If these operator are commuting, that is commutator is equals to 0. If these are commuting, then the product of these commuting operator, that is P1 and P2. If we take their product and it is like this one, it should obey the condition P transpose is equals to P2 into P1 transpose, and it should be equals to P2 P1, and or it should be equals to P1 P2. So the product of these commuting operator will also be the projection operator. So their product should also be the projection operator. So this is the first property of projection operator. If you have the two projection operator P1 and P2 and these are commuting, then their product P1 P2 will also be the projection operator because it fulfill the condition for of hermiticity, and P square is equals to P. So this is the first condition. And second condition, like P1 P2 square, it should be equals to P1 P2 P1 P2. So its square will be like this one, and we can write it like P1 square P2 square. So it fulfill both the condition for the projection operator, that is the product of two operator fulfill both the condition of the projection operator. So their product of two commuting projection operator is also a projection operator. Okay. Now the second property of the projection operator, which is related to the sum, is that the sum of projection operator, the sum of projection operators, if you have more than one, that is two or three projection operator, then the sum of these projection operators is generally not a projector, is generally not a projector. Okay. Now another property of the projection operator is that let we have a two projection operator, and that is two projection operator. The two projection operator like P1 and P2 said to be orthogonal, said to be orthogonal when they said to be orthogonal when their product is equals to 0, when their product is equal to 0, like P1, if P1 P2 is equals to 0, then these two operators are orthogonal to each other. So this is the property of projection operator. Let we have another property of the projection operator, and other property of projection operator is that it is also related to the sum of the projectors, like for a sum of projectors, if you have like P1 plus P2 plus P3 up to so on, so these are to be the projector. Generally we have learned that generally the sum of the projection operator is not a projector. So the sum of the projector can be a projector, but it should fulfill the necessary condition is that these projectors are mutually orthogonal to each other. So these projector should be orthogonal to each other. So this is the condition for the for the sum to be a projector. Let's suppose from here, from this sum, we have any two projector P1 and plus P2. So there these should be, that is their sum of any two. If we take any two projector, then it should be their product should be equals to 0. That is these projector, then only this sum will be a projector. Otherwise the sum of projection operator is generally not a projector. In order to fully understand the projection operator, let's we have an example, and let's we have an operator like psi and psi. This is an operator, and we need to prove that either it is the projection operator or not projection operator. And for the projection operator, we know that first it should be the Hermitian. Now first we check that either it is Hermitian or not. So let's psi into psi transpose should be, and you know that whenever we take the transpose of bracket notation, Kit change into the broad notation and broad change into the Kit notation. So here both functions are the same. So psi into psi transpose of this quantity is this remains the same. So it means that it is Hermitian. Now we need to check the second condition, that is the square of this operator should be equals to this one operator. Now we have the square of this operator as another here is that condition is that the psi is normalized. This is the normalized function. So here we consider we'll consider the normalization condition as well. So when we take its square is like this one. So this is the square. So here this quantity as a psi function is the same, bracket both are the same. So this is one will be equals to 1, as this is the normalized psi is the normalized. So this product of bracket notation is equals to 1. So remaining quantity can be written as psi into psi. So the product of psi into psi whole square is equals to this operator. So it fulfills both the condition for the projection operator. So we can say that this quantity is the projector. Okay, it is a projector because it fulfill both the condition for projection operator. So this was the all about the projection operator, that how any projection operator is the projection operator and what are the necessary condition and properties for the projection operator. Thanks for watching. For more videos, please subscribe our channel.